Welcome to Talking Data Equity for Friday, October 25th. I'm very, very excited that you are all here. And my name is Heather Kraus. I am a mathematical statistician and the founder of an organization called We All Count. And the purpose of We All Count is to provide tools and training and community for anybody who is trying to embed equity in quantitative work, anybody who's trying to align the choices they're making when they're working with math and statistics with the equity goals that that project has. And one of the things that We All Count does a lot of Fridays at this time is we run something called Talking Data Equity, which is an informal drop-in, no-charge group that anybody who's interested in the practice of data equity can attend. And we run it on Zoom. The Zoom link is the same every week. So if you've made it here today, you can make it here any other Friday. And sometimes we have special guests, and sometimes we talk about specific topics. And sometimes we just have wide open, like, talk about what resources you need, and we do a resource exchange. It's completely different every week. And this week, we have something super cool that I know some of you are here for the first time to get this great opportunity. Today, we do have a special guest speaker, and our special guest speaker is Dr. Clare Evans. And I'm going to do a brief intro, then I'm going to turn the session over to Dr. Evans, and Dr. Evans will spend some time sharing some very, very cool tools that she's built and some examples and some stories. And while she's specifically sharing her stories and her slides, we're going to ask that you keep your microphone turned off. You can feel free to use the chat all throughout the presentation, but we're going to ask that you keep your microphone turned off for the first part. And then once Dr. Evans is done sharing, that's when we're going to have a live Q&A, and you can ask questions in the chat. You can ask questions with your microphone on, all that good stuff. So some of you already know Dr. Evans' work quite well, and some of you are in for a treat of learning about it for the first time. Clare Evans is an associate professor in the Department of Sociology and co-director of the Global Health Program at the University of Oregon. She also serves on the executive leadership team for disability studies and received her SCD in social and behavioral sciences at the Harvard T.H. Chan School of Public Health in 2015. She also received an MPH, which I believe is a Master of Public Health in Socio-Medical Sciences at Columbia University Mailman School of Public Health in 2011. Clare is a social epidemiologist, a medical sociologist, and a quantitative methodologist, right? That's what I want to be when I grow up. Her research focuses on the intersectional social determinants of population health inequalities. And in 2015, Dr. Evans proposed using a very specific technique called hierarchical multi-level models to evaluate intersectional health inequalities. It's going so well that it now has its own name. It's now called intersectional. Now, I don't actually know how to pronounce it. I always say MAIHDA, but one of my first questions to Clare is going to be, how do you pronounce it? Recently, Clare proposed and developed further extensions of the approach, including multi-categorical MAIHDA for use in the clinical and biomedical sciences, random slopes MAIHDA for complex study and analytical designs, and eco-intersectional multi-level modeling, which is amazing. I have to say, my mind was blown, and I was so excited when I read that paper. So wherever you are on the technical spectrum of using data, I really encourage you to hang in there with this talk, and don't get upset if there's parts of it that you don't understand every technical word. Just kind of like get on the boat and float around on the boat, because this is a really cool idea that is useful to lots of different people with lots of different technical experiences. Clare, I cannot say how excited I am that you are here. Been a big fan for a very long time, and thanks for making space in your really big, busy schedule.
Thank you so much, Heather. And I'm so delighted to join this group today. I am really impressed at this idea of people doing all kinds of different work in different programs, institutes, different research missions coming together to have these kind of conversations. I'm thrilled to be here, really. And for the record, I don't know how it's pronounced either, because while I had the idea, I wasn't actually the person who came up with the acronym. I think it's a bit of a mouthful. I always say MAIHDA, but you are welcome to say whatever you'd like. This could be a potato thing. So yes, I'm here to talk about this today. And again, for those who don't have as much background in multi-level modeling, that's fine. I'm here to talk to you as well today. And I hope I'll have some ideas that you can walk out with and think about in your own work today, even if you have less experience with multi-level modeling. So on that note, just to kind of get us all on the same page, uh, for those who are less familiar with multi-level models, or for those who are familiar with it and want a place to reorient yourself, in multi-level modeling, we're basically thinking about data with clusters in it. So we might have individual respondents that were students in schools, and we have many schools in our data set. So we might say that those students are clustered by school, or we could have residents clustered by neighborhood with multiple neighborhoods in our data set. We could have workers clustered by their workplaces. And the familiar rationale behind this, even if you're less sort of versed in the mathematics of it, is when you share environments, you can have people with correlated outcomes. In other words, your different observations of students in the same school are not going to be completely independent as if they were drawn from a population at random because they share an environment. There are things that they have in common, the built environment, the social environment. Now, historically, we've thought of multi-level models for clustering of really concrete things that we can see or touch or recognize quite easily. So these could be things like, again, schools, neighborhoods, workplaces. But multi-level modeling is one of my big plugs today, much more capable of handling broader ideas than that. Multi-level models also allow us to think about variation. So instead of just saying, here's the average difference, or if we want to think about it differently, inequality between schools or inequality between populations, we're also encouraged in multi-level modeling to think about variation around those averages, variation of observations within a school, variation between schools. So it's a different kind of light for thinking about inequality. If you leave here today with just two big ideas kind of implanted in your thoughts, I hope it's these two. First of all, I think we can do a better job of estimating inequalities than we've been doing in the past. No shade on past work, but I think we can do a little bit better. And I think the reason you're all probably here today is because you feel the same way. Many of us would like to see, for instance, expanded diversity in our consideration of inequalities. Who gets counted? What is visible and what is invisible? These are important questions to all of us. We should also be thinking about the metrics that we use to assess inequality. We tend to fall back on just one or two of them, looking at averages or average differences, but there's lots of different ways to understand patterns of inequality and inequity in populations. And then finally, we all have this constant concern about how robust is my estimate here? How reliable is this estimate? Particularly as I expand the diversity that I'm considering in my research, my sample sizes start getting smaller and smaller. How can I try and maximize the reliability of the estimates I'm getting, even with smaller sample sizes? So when I say I think we can do a better job of estimating inequalities, those are the kind of targets that I'm talking about. The second big idea here, again, is that multi-level models are way more flexible than we've been thinking about them for the last quarter century. They can handle much more abstract types of clustering than we're used to thinking about. So if I were to bring this into a slightly more unfamiliar realm, we could think about individuals in our data set as being clustered by something abstract, like their intersectional positionality in society. So I call these intersectional social strata in order to get away from the use of the term groups, because not everyone's a social group, not everyone's a friend with each other. You can have people on opposite sides of the country who occupy the same positionality in society by virtue of their identities, their socioeconomic position. And because they share that positionality, they might also share other things. So this gets back to that familiar rationale. They might share similar kinds of opportunities, similar kinds of disadvantages. They might face similar forms of discrimination. That can create the same kind of clustering in our data that we see when we talk about residents in a neighborhood. So multi-level models, if we expand how we think of clusters, allow us to start to think about intersectional inequities a little bit more seriously. And in an even more abstract way than that, we can think about high dimensional interactions. That is, effect measure modification with lots of interaction going on between different variables. So this is quite an unfamiliar setup. I'm going to walk through some key questions here in the next, half hour or so. Why would we do this in the first place? Why are we thinking about intersectionality? I probably don't have to sell you all too hard on that first point, but I'll give it a shout out. Why do we need a new approach? This is where I'm going to spend a hearty bit of time. Why is it that we need a new approach when it seems like we already have tools that do this, that we know and use often? Number three, what is the difference between intersectional experiences and interaction effects? This one I throw in there just because I see this mistake made a lot. It's a really common misunderstanding, and so I want to make sure there's some clarity around that. And finally, I want to give you a whirlwind tour of just some brief recent examples that my research team and others have been working on recently using MAIHDA. And I think through those examples, we'll start to see how it is helping us to do a better job of estimating inequalities that we're interested in. So starting out with, why are we doing this? Why study high dimensional interaction? Why think about intersectionality? I'm coming from the realm of population health research and social epidemiology. I know we have a mixed group here. Maybe your interest is in educational inequalities. Maybe it's in environmental justice. So this is just coming from my field. But if you look at any theories of population health inequality, any of the big ones, they have a similar theme that comes out that we need to pay attention to multiple axes of marginalization. So sexism, racism, homophobia, all of these, as well as socioeconomic inequality. These are all important as determinants of health and determinants of health inequalities. We see similar themes across the social sciences. We see it throughout the health and medical sciences, social work, environmental sciences, environmental justice, and even beyond. And then we have intersectionality, which we are starting to see the connection between these domain-specific theories that are speaking to the ideas of intersectionality. We now see intersectionality being brought in increasingly and applied in these fields because it's a way of tying these ideas together. It's a way of theorizing inequities that is more of a coalition of these different critical ideas. So intersectionality, as you probably all well know, but just to get everyone on the same page, comes to us from Black feminist scholars and activists like Patricia Hill Collins, Kimberly Crenshaw, really leaders in the field. And they proposed this critical theory and also analysis framework for understanding that those different systems of privilege and oppression aren't just operating separately. You can't talk about one without also thinking about the others. They are interlocking and inseparable. A big part of intersectionality is centering the experiences of the marginalized. Historically, of course, this meant Black women, but we might think about other underseen, understood groups as well. We, of course, need to think about many axes of marginalization, so have an expanded view of these different axes of oppression that we should think about. So not just race, class, gender, but sexuality, immigration. We should think about disability. We should be thinking about age. And then, of course, a very important part of intersectionality is it's not enough just to talk about it. You should be critiquing. It is a critical theory, but also aiming to transform. So how can we use what we're doing to try and actually make the world better? I will try to circle back to that towards the end here. So as we take intersectionality, which was not originally meant as a quantitative method, but we import it to the realm of quantitative research, we are often doing what Leslie McCall has called intercategorical intersectional analysis, which means we're going to at least provisionally use labels or categories in order to divide up our population and then measure the inequality between those populations. So it's a measure of inequality. We are going to very much explicitly theorize these different markers of identity and status, not as things that are inherently causally meaningful themselves, but because they are proxies for social experiences. So in other words, rather than really meaning race, if we're putting race-looking variables into our model, we are thinking about how these are representing positionalities within racist systems. So how can racism affect health inequalities, for instance? And then very explicitly, we are rejecting an additive approach here. So the simple equation is, being a Black woman is not the same as Blackness plus womanness. We have to think about how there might be unique experiences and therefore perhaps unique outcomes at every intersectional positionality that we're thinking about. Okay, so question 2, why do we need a new approach? It seems like we have something that already does this. We're used to using single level regression models, what I'm going to call the fixed effects approach. A really simplified example here, we might have some health outcome or some other kind of outcome for individual I in our data set. And let's say we just have, again, very simple men and women and Blacks and whites in our population. We might use an equation like this with 4 different fixed effects to try to estimate a unique level of that outcome in each of these 4 different groups that we've defined: Black women, Black men, white men. And here in particular, the interaction term woman in Black is the term that allows Black women to have a different unique effect beyond whatever woman in Black are representing here. There's a number of critiques of this approach, some theory ones that are in the literature but less talked about, I think. First of all, if we keep referencing more privileged strata as our reference group, very often it ends up being sort of high SES white men. Is there a possibility that we are accidentally reinforcing the idea that these privileged groups are somehow occupying some kind of social primacy? In other words, they're the yardstick against which everybody else gets measured. So by trying to highlight the experiences of Black women, are we unintentionally reinforcing the idea that white men are the default human? There's also something about this, point number 2 here. I don't know what it is. Maybe it's a quirk of human brains, but when we look at these equations and then we run a regression model and get our results, we all immediately start comparing the size of these betas. And we all ask, okay, so is beta 2 bigger than beta 1? Oh, that must mean that it's really a story of race and not gender. Forgetting almost immediately that we are saying that these are inseparable. We are reverting back to single axis thinking when we really want to stay intersectional in our thinking all the way through our interpretation here. And then this also raises the question, what about intersectional interaction effects for other social strata? Isn't it also true that there's unique experiences for Black men or for white women or even for white men? So might it make more sense to think about additivity as what is the sort of typical pattern, and then interaction as who's standing out from those typical patterns? In other words, could we compare groups to themselves if they were working only under this additive regime? Methodologically, there's a bunch of issues here. So it's perfectly fine if you have 4 groups, not much of an issue. But what if you have a lot more things you're told to include in your model? Just like intersectionality asks us to do. Okay, I want to think about disability status. I want to think about ageism. I want to think about sexual orientation. Suddenly, my number of predictors is growing. And it's fine if I'm looking at the additive effects, but all of the different permutations of interactions that I need to include mean the number of beta terms is growing geometrically. So we very quickly run into issues with scalability and model parsimony, where this tool just really isn't scalable enough to live up to what we are wanting to do according to the theory and our equity work. We also, very importantly, start running into some problems with sample sizes pretty quickly. Even if you start out with tens of thousands of people, you're going to start to get intersections that have pretty small sample sizes, less than 5 people even. And if you're just calculating an average among 5 people, that could be a quite unstable estimate. You could get some real unreliable results there. With this, we also face what Juan Merlo and others have called the tyranny of the averages problem. We are encouraged to look at the betas, our estimates of averages and average differences, with much less focus on variation around those averages. And then finally, if you have 400 beta terms in, I don't care how in your data you are, you're going to start to struggle to interpret your results. let alone communicate them to others and sort of pull out the meaningful findings. So we have lots of critiques here. And this is where MAIHDA comes in. MAIHDA stands for Multi-Level Analysis of Individual Heterogeneity and Discriminatory Accuracy. When I first came up with this, I just called it the multi-level intersectional approach, but this ended up fitting a little bit better in the literature. So again, the idea here is we're going to think about individuals at level 1 in our data, clustered by each of the unique combinations of identities and positionalities that we're trying to analyze. So for instance, we'll have a unique cluster, perhaps, for Black women with a college degree who are high middle income, aged 30 to 44 years old, and so on and so forth for all of those combinations of variables. So if I were to compare the two approaches, MAIHDA right off the bat looks a little more complicated. So our single level approach, again, we're just keeping it kind of simple here with just the 4 social strata. I wouldn't actually recommend fitting a multi-level model with only 4 clusters, but just for the purposes of illustration to keep things simple, I'm going to write this model as if we're only doing 4. Realistically, you want a lot more than that. So typically you're going to fit 2 models. Your first one is a null or empty model. You haven't put much in there. So your beta 0, your intercept is what is the overall average across all of my strata? And then mu j is, okay, how is the average in this social stratum, number j, different from that overall average? And you estimate a unique value of that for each of your strata. And then you have your little E term left over. How is each individual in that group different from their group's average? Right? So pretty simple. Model 2, we just put in the additive parts of the variables, the additive main effects. So in this case, we would have woman and Black. If we had other categories, we might have high income or rich, whatever, younger, whatever our additive main effects are. Once we've done that, then the residual at the group or stratum level is sort of like that interaction term. It's whatever is left over that we need to include to explain how that group has a unique average value. And so importantly, we are estimating this interaction effect for all of the social strata, not just a few of them. That's a useful thing. In these multi-level models, we're also thinking about how our mu j's and also our EJs are variance terms. They are distributed with distributions. So we're going to get an estimate of between strata variance and within stratum variance as well. We're not just thinking about additive effects. Okay, so why do we need this? It seems more complicated. I have to fit multiple models. There's new moving pieces like variances. What does this give me for this little bit of extra added complexity? Well, first of all, again, I mentioned as your fixed effects start increasing in your model, you start adding in there sexual orientation, immigration status, disability, your number of betas in that fixed effects approach grows geometrically. So here we see that where I've taken the same theoretical data set, I've split it up by a number of different strata. So I go from my 4 that we were just talking about up to 384 different groups, right? Bayesian information criterion is a measure of goodness of fit where it's saying we're going to measure the goodness of the fit, but also how much does every additional thing you put in the model actually add? So it's going to penalize you a little bit if you have to add a bunch of things to the model in order to get that goodness of fit. And as we can see, the fixed effects approach explodes. Higher number here is less good. Whereas the MAIHDA approach, the multi-level approach, is still going to increase the number of betas we have to add. We're still adding woman and Black and high income to the model, but we don't have all those interaction terms. That saves us a lot of additional fixed effects we are not having to estimate. So the betas increase linearly as we go. And as a consequence, we get a lot of additional explanatory power for each of those additions. So it's a much more scalable approach. We get a lot more model parsimony. And then also at a human level, it's a lot easier to interpret. You have fewer moving pieces, fewer parameters to understand. So that's going to be easier to think about the results from. There's also the issue that in the fixed effects approach, this is a bit of a snarky question, really, but are we really just doing a fancy method to calculate an average? Couldn't we get the same thing by just doing a really extensive cross tabulation in whatever software we're doing? Because essentially what we're doing in the multi-level, in the fixed effects approach, is taking our sample. So here I've got this hypothetical data set of people's hemoglobin A1Cs. So this is average blood sugars. Some people have low and high values. Here's our sample mean. I'm going to split my sample into a bunch of different groups. And then I'm going to calculate the average in each of those groups. That's essentially all this is doing. Unless I'm adding other things into the model, that's all that this fixed effects approach is doing. And if that average for a particular group is based on only a few people, that's my average. There's no way to handle that. Again, I'm also thinking only about averages. So if I move into multi-level world, I'm actually thinking, first of all, about averages, but also variation. I'm thinking about what is the distribution within strata. And then if I take my average values and bring that back up to plot the averages for my strata, I'm thinking about variation across my strata. So the multi-level approach, just by nature of how it's built, is going to be helping us to overcome that tyranny of the averages problem. I'm going to be less likely to look at an average difference between groups and say one group is high risk and the other's low risk, and miss the fact that their distributions are so well overlapped that those aren't really good descriptors at all for what's going on. So it's important to pay attention to variation. I actually pulled a fast one on you on the previous slide. I'll go back just a minute. Here, we were talking about averages, and then I showed you a plot with the averages for each of my strata, but those are actually from the fixed effects approach. I can calculate an average for each group from the fixed effects approach. The multi-level approach is actually giving me not averages for each group, but precision-weighted averages. So in other words, instead of having a grand mean, the average of the averages, I have a precision-weighted grand mean. Now, what does that mean in practice? We can see it best here. Some of those strata, like I mentioned, might have really small sample sizes. So it's going to give us estimates for those groups that are really small. Maybe just because I happen to have only a few people in that group who had really small values or really high values. The multi-level model is going to take into account what those estimates are, but then also precision weight it. So in other words, it's going to adjust for the sample size, giving me a much more reliable and robust estimate, even when my sample size is small. And this has been validated by independent teams now, including some amazing epidemiologists like Greta Bauer and others. They're finding that MAIHDA is capable of handling smaller sample sizes than we are accustomed to thinking about and having comfort with in our quantitative analyses. So just to kind of put a bow on this, from a theory perspective, we are not specifying one strata as the group against which everybody else gets compared. We're comparing groups with themselves in a world where everything's additive. So this helps us to get away from this problem of reinforcing the primacy of the multiply privileged. It's also a lot easier to remain intersectional. We're looking at different interactions for all of our groups. We have fewer things to keep an eye on, so we don't have that temptation to simplify just for interpretability. We also get interaction effects for all of our strata, which is quite nice. Importantly, as we start adding more and more things into that model, as theory asks us to do, we are going to be growing our model linearly rather than geometrically. So we get improved scalability, better model parsimony. Again, important finding like we just looked at, we are adjusting for sample size. So we get better estimates, even in smaller groups. We're getting away from this tyranny of the averages problem by thinking about variation as well as averages. And it's easier to summarize and interpret our findings, find the meaningful things, and then hopefully go do something with that information, which is getting back to transformation. Okay, so finally, a pet peeve of mine. People confuse these all the time. So I often get asked, if I run a intersectional model, be it MAIHDA or the fixed effects approach, what if I find that there's no statistically significant interaction going on? I find nothing. Did I just disprove intersectionality theory? Ooh, better rush to publish my paper. The answer is no. That's very much not what you're doing. That's not what that means. So for a quick analogy, imagine, people walking along a beach. The foot here is the experiences people might have within interlocking systems of oppression. Those can be unique. They are real. They exist. We understand that they exist. What we are doing is looking at footprints. Did those experiences happen to leave a footprint on that particular outcome in that particular population at that particular point in time? And did it require interaction terms to describe it? Maybe all of the inequality is quote unquote predictable. We tend to see some privileged group consistently doing better, regardless of how old or young they are, or how rich or how poor they are, right? That would just mean we have a very additive inequality happening. It doesn't mean the inequalities are insignificant, and it doesn't disprove intersectionality theory. So, in other words, we aren't testing intersectionality theory, we're using it to structure our questions. And then we're looking for what kinds of patterns of inequality we can find. We're estimating the effect of intersectional social experiences on a particular outcome. And then I always have to put in a plug for this, especially with health research. Remember to reject reification and biological determinism. Think about social determinants, right? Okay, so some brief examples, and this truly is a whirlwind tour here, so hang on. My goal with this is to just give you a little taste of what's possible if you're using this kind of an approach. So how can MAIHDA help us to do a better job of estimating inequalities? Well, my first example is coming from some work I did a few years ago using the 2015 National Survey on Drug Use and Health in the United States. Cross-sectional survey representative of the US non-institutionalized population, age 18 and plus. So in this, we were interested in prescription opioid misuse. So respondents to this survey said, in the past year, did I use a prescription opioid in some way other than my doctor prescribed? Yes or no? And we have, more or less the familiar types of variables that might show up on a large survey like this. I personally, wish there was more gender diversity here. Different categories had been included. I wish we could have included more things like disability status, but we don't always have those in these large surveys. But even here, with a pretty limited set of options and variables, we can still see how that just gives us 72 strata, which is quite a lot. We would need 72 beta terms in our fixed effects approach in order to do the equivalent model there. So if I were to go dig, which we did, into the opioid literature, I might quickly come to some sort of general expectations just based on the kinds of research that research results are typically put out. If I look at additive inequalities, which is how we usually think about it, people might look at it by age or by race, ethnicity, or gender. I might start to form the expectation that the groups that are at the highest risk are going to be sort of middle age or older, white, predominantly men, and low and middle income. So if we actually fit the MAIHDA model to this data, and then we plot the predicted probability of saying, yes, I have misused prescription opioids in the last year by group, what do we get? Well, we plot it ranked low to high. All right, give you a moment here. I've labeled all of them, so it's a little hard to read. I'll just say, let's pay attention to the top 10, the highest risk 10 groups. Well, clearly, not all of them are that middle age and older as we expected. Many of them are actually younger, the sort of 18 to 29 range. Certainly not all of these strata are white. Not all of them are men. And we actually have the full income spectrum, including high income strata. If we zoom in a little further even, our highest risk group maybe is sort of in line with our expectations, younger, low income white men at the highest risk. But ranked number 2 is a big surprise. Younger, high-income Black women are the second highest risk group. This was entirely invisible to us when we were looking at the world in an additive way, only thinking about race, ethnicity, or only thinking about gender. This group that's so much higher risk was completely invisible. So good research here should lead us to further questions, starting with, well, Black women, that's unusual. All of the other Black women strata in this analysis are actually in the mid to lower risk part of the distribution. So what's going on that might be unique with this group? Asking those kinds of questions can really help us to challenge our current understanding of inequalities and reveal things that have been unseen for a while. Are there high risk strata we didn't see before? Could this enrich our theory? Why might these strata be higher risk than we expected? Having sat with this for a little while, my personal expectation, if we delve into this in the future, perhaps with some more qualitative work or further quantitative work, is going to be the reason we have a high risk group here with high income younger Black women is the footprint left by medical racism. That would be my personal suspicion. So again, this is not necessarily street drug use or other kinds of illicit use. This is, I am using prescription opioids other than how my doctor prescribed. We know that Black women in particular have inadequate pain management after surgeries or to deal with any number of conditions or after childbirth. So which group is going to be the most likely to realize I'm in pain. My doctor is underprescribing this for me. There could be some issue going on here. Misogyny meets racism. I'm going to not do quite what they tell me. I'm going to feel a little bit more comfortable taking a stand and being proactive about my own health and my own pain management. So, what we're seeing here could be worrisome, problematic use, or it could just be self defense in a system that's not set up to support their adequate pain management. So, this is the kind of thing that we can see and the kind of thing that can spur new and better questions when we start to approach this with intersectional thinking. I had to work a picture of my kids in here somewhere. So here's where this next example comes from. Thinking about twins and singleton birth weight. So I have an older daughter and younger twin sons. Their birth weights had a bit of a gap. So my singleton daughter was 3,062 grams at birth. The average birth weight for my sons was 2,800 grams. So this would give us a difference of about 255 grams. This is very expected, right? There's only so much room in me as a human to grow two humans. We expect twins to be smaller. Growth restriction, we expect that there can be any number of health issues that can go wrong in a pregnancy. We expect, twin-to-twin transfusion syndrome, depending on what kind of twins they are. There's any number of reasons we expect twins to have a lower birth weight. They're born earlier, maybe. But we rarely study the birth weight gap. We end up kind of relegating this to the realm of purely biomedical understanding rather than recognizing that we actually know that the birth weight gap is modifiable. And in theory, we want babies to all be born not underweight or very underweight, right? We know it's modifiable with resources, things like good prenatal care, good nutrition, rest, good monitoring towards the end of pregnancy. There's all kinds of things that can modify this gap. Those resources we also know are going to be unequally patterned across strata in society. So this kind of question is a MAIHDA question. We're asking an intersectional question, but it's a little different than the one I just showed you. We're going to ask, is the effect of something X on outcome Y different in my different intersectional subgroups? This is an effect measure modification question. For this, we have already established a whole literature for multi-level modeling around random slopes and random coefficients. So my question here is the effect of being a twin versus a singleton on birth weight different in different intersectional groups? So if I had to draw a picture, is the effect of being a twin on birth weight affected by which intersectional strata you belong to? So for this, we fit a slightly more complex version of the model, but it's not too different. It's more or less the same thing we've seen before, but I'm adding in twin status as a level 1 variable, and I'm making it a random slope or random coefficient term. So now I'm going to be thinking about variation between strata among singletons and variation between strata among twins, as well as within each strata, what's the gap? Okay, so I get all kinds of different snapshots on the inequalities happening here. And I can make some pretty charts with results like this. I can pick out any particular group, comparing singletons and twins, and see how big is the gap for this maternal age, this race ethnicity, whether they were foreign born or not, what level of education did they have. I can look at the data in a lot of different ways. But getting back to that original question, how large is the birth weight gap? Well, the between stratum birth weight gap for a particular group is going to be given by this: the overall birth weight gap plus whatever was unique to the gap for that group. So overall, in the whole sample, generally speaking, twins are about 930 grams smaller on average at birth than singletons, which is a big gap. We saw that in that previous picture. But how much variation is there in that gap size? It turns out quite a lot. So here I've charted from sort of lowest to highest values, the size of that gap modification for each of my strata. And what I see is from that average, you can go plus 100 grams or minus 100 grams. So a really huge range, very clinically meaningful range in the size of that gap. So what that tells me is there's a lot of babies being born significantly underweight that don't have to be if we were making sure to allocate resources more equitably. We also see larger inequalities. So there's more variation between strata among twins than among singletons. So we see more inequalities in birth weight across strata. Similar kind of question, totally different example. We all know that 2020 was pretty rough on everybody. We know that there's been a big mental health crisis, and there's been a lot of conversation about the youth mental health crisis here in the United States, as well as elsewhere. So what if we were to ask pre versus post 2020, what happened to mental health for teenagers? And was it different, that change different in different intersectional strata? So again, it's a random slopes, random coefficients model question. So I could chart something like this. This is from some under review work that we're doing, looking at self-reported suicidal ideation. So a pretty significant marker of mental health. Now I can chart, low to higher risk. And for each of these strata here in the square marker, I have my pre-2020 result from 2017, 2019, and then circle is post-2020, so from 2021. Now, interestingly, what I see is the range is pretty big, and it hasn't changed much for the groups at the high end and the low end. My heterosexual men or young boys and girls of all different race ethnicities, they tend to be at the lower risk end, though 10% is still wildly alarming to me. And at the high end, especially young bisexual girls, they tend to have much higher risk, but not much change on either end. But we have seen a wild swing in risk towards significantly more reports of suicidal ideation for the middle of the pack, particularly those who are racially minoritized and some sexual orientation other than straight. So these kind of questions, again, these are random slopes, random coefficients questions. That allows us to bring MAIHDA into a realm where we can ask a whole bunch of new kinds of questions. We can ask about effect measure modification. We could perhaps do mediation analyses. We can start to think about different contexts, policy environments, and reintegrate consideration of context into our multi-level and intersectional models. This opens the door to longitudinal analysis, either with repeated cross-sections or panel data. And we could even get into things like regression discontinuity or splined models. Just a quick flavor of that, we could think about mental health trends by generation. So this is from a recent paper looking at how different cohorts in the UK have been progressing in mental health. Mostly as they've gotten older, each of these cohorts we see in this panel data are going towards worse mental health, with possibly the exception of the boomer generation. But we can split this up intersectionally now to look much more nuancedly at race and ethnicity inequalities, gender inequalities, education inequalities, and so on. For those of you doing environmental justice work, we can think about, instead of individuals clustered by intersectional strata, we can think about intersectionality at the community level. Whole communities get exposed disproportionately to environmental hazards. We've talked about environmental racism and classism in the EJ literature. Let's think about how neighborhoods like census tracts are clustered by different strata of sociodemographic profiles and how that could relate to risk. When we do that, here we're looking at excess cases of cancer attributable to air toxics exposures. We see more or less the ubiquitous story that we are expecting from environmental justice. The highest risk groups that are considerably higher risk, actually, tend to be Black, have more single mother households, have lower education, and this includes even the higher income versions of those communities. On the lower risk end, we tend to see whiter communities with lower percent single mother households and the sort of higher and mid education and income range. Same kind of analysis, but thinking about industrial air toxics exposures. And we could think about this in terms of subregions within, for instance, Appalachia. We could say, how big are the inequalities in exposure to air toxics in different parts of Appalachia? And if we got data on it, how does that compare with mining or other kinds of environmental hazards? So we can start to think longitudinally. We can start to think about inequalities in geographies, as well as inequalities with individual data. So how does this help us to do a better job of estimating these inequalities? Well, I hope that you're starting to see from this, first of all, we can still map averages and probabilities, just like we were doing before, but with more reliable results. We're also encouraged to think about variation within and between groups. And we get estimates for interaction effects for everybody, not just some groups. In terms of the broader aims here, this is going to support our mission to expanding diversity in our research and being more inclusive in who we count. Not to plug the name of the, the group. We can think about challenging all of the dominant narratives and conventional wisdoms out there and finding things that haven't been seen or appreciated before. Perhaps identifying high-risk groups that are in need of greater attention, support, or resources. We can identify inequities, those gaps, like the birth weight gap I was talking about, where we could be doing more to help more people. We can avoid that tyranny of the averages problem. We can recognize variation and heterogeneity of experiences, even while quantifying inequalities. And then I changed the color on these to really make them stand out. I hope we use this to critique those systems of oppression and those power structures with the ultimate goal of transformation, because that's really what we're doing here. So that brings me to my big thank you. And do you have any questions?
Thank you so much, Claire. That was such a great presentation. I really appreciate your mix of talking to us about the ideas and talking to us about the math. And really, really helpful. As you can see in the chat, there's a lot of applause and hearts
Thank
and
you.
and a lot of appreciation, already requests for classes. I am going to, there are a lot of questions, and I am going to start with one that is written down in the chat. And if you're here and you want to raise your hand and turn your mic on, I will go to you second. And the short answer to all the questions about, is this being recorded? Yes, and we will share the link with you. So here's the question. Would you mind commenting on the application of precision weighting shrinkage in a context like pay equity analysis, where one wants to estimate a salary discrepancy for a historically marginalized group? I get that precision weighting produces greater shrinkage for smaller groups, since a marginalized group may be underrepresented because of the same factors that contributed to lower pay. The larger shrinkage seems like it might act as an additional penalty. It achieves a greater statistical estimate, a better statistical estimate, but a worse ethical estimate in the setting of salary discrepancy for the group. That's
This is
very
such a
specific, but just wondering if that has ever crossed your desk yet.
Yes, no, this is such a great question. And to be clear, I haven't done specifically research on pay equity. So take this with the grain of salt. In your particular field, you're probably way more of an expert than I am. I can speak more generally to how does it affect things when you have smaller groups that you want to include, but you're worried that you have a bad estimate for them, like what's going on. I think what you're speaking to is the fact that precision weighting could end up being a more conservative estimate, right? So if you have a smaller group of people, then is the model going to be sort of penalizing and dragging that group towards the overall average? And might that underestimate how bad the inequity was? And to your question of ethics, I imagine that's kind of where that's coming from. Are we doing a disservice by using this? So first of all, I have lots of thoughts. First of all, very often when we're making these justice and equity arguments, we're facing down critics who are going to say things like, well, you have a small sample size and that's unreliable. It could be not very bad at all, or it could be really bad. You don't know. There's so much variation around that average that you have for that group. So how can we know this? So an advantage of feeling like your result is, if anything, going to be a little bit conservative is that whatever you detect, you can be darn certain it's there, right? Or at least more certain. I don't know your data set. Another thing is that shrinkage is much larger in the null version of the model. So this is actually a useful subtlety here. I actually recommend, based on all the simulation work that we've done around this, that if you're going to use one of the two MAIHDA models to give you your final predicted values, use the second one. Use that one. So an example here is, what if I have Native American genderqueer PhDs in my data set? I don't often get to analyze them because I'm lucky if I have, 2 or 3 of them, even in a very large sample. But I don't want to recombine them with another group. I don't want to drop them completely from my analysis and invisibilize them. So a good question is, how am I getting a prediction for that group based on 2, 3, 4, 5 people? That seems like way too little data, right? So what we're actually doing in a multi-level model is very different than that fixed effects approach where we're just straight taking the average of that small group. We're actually estimating for that strata based on all of the betas combined from these different groups. So we're going to use the beta for Native American, which is pooling information from other strata of Native Americans, other PhDs, pool information, other genderqueer individuals, pool that information. Now, yes, this could give us a result that's slightly off, but generally speaking, at least in the health world, we're finding that a lot of the inequalities are dominantly additively patterned, like 80 to 95% of the inequality is accounted for by expected additive patterns. So you get in the right ballpark right away, even with a pretty small sample size. And then the part that's shrunk is the residual, not those betas. And so if it's already kind of small to begin with and you don't have a lot of data, yes, you'll see more shrinkage, but it tends to be on a smaller piece of the pie. So yes, we might end up with a slightly off estimate, but this is a bias variance trade-off. There's a whole literature on this. By allowing in just a little bit of potential bias, we counterintuitively end up with a better estimate, even with that small group. So in other words, it lets you be more inclusive. But this is a fantastic question. Yeah.
It was a fantastic answer. And as you can see, there are many, 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 many questions.
Oh,
And
and I'm
so
seeing one about citations. Let me just page ahead really quick. So since it's in the
great.
recording, you'll have it here. I've tried to organize it by topic
Perfect.
and some more references. I want to give a plug to this brand new out this year. We have a tutorial, and it has
Ah,
a downloadable data set with example code in Stata and R. Other software coming, but you can download it and play around with that toy data set. It walks you through it step by step, how to think about it and how to actually start executing this, so that you can then model that for your own work.
perfect. That is really, really helpful. And we will absolutely link to these citations and resources that are being shared by Claire here. And if you don't belong to an academic organization and some of these resources you want to read, but you don't have a subscription, email me personally, heather@weallcount.com, and we will set you up. Um, Claire, can you go back just 2 or 3 slides to the one that,
Yes.
yeah, that one, because there's a couple
Yes.
of people that really want to write that down. And I think we have time for one more question. And I know that there's so many, but there's multiple people asking about missing data. And again, I don't want to put you on the spot. Don't know if this has come across your desk yet while you're inventing an entirely new methodology, but uh is there a way to assess or think through like the ways that different strata are missing?
Mm. So is the question, I could go in a lot of directions with this. Is the
Yeah.
question about missing data, does this help us deal with missing data problems, or is it more about which strata are missing?
It's more the second. Like, is it a really big problem if a couple of the strata are missing entirely, or like 4 out of the 6 characteristics or social determinants of health are missing for individuals?
So this is definitely where art meets science a bit when you're
Yeah.
defining your strata. And I spend
Yeah.
a fair bit of time in the tutorial talking about this, but I found that even that's not enough. A lot of the support work and consulting work I do these days ends up being about helping people to kind of come up with the best compromise between, I wish I could include all of these different categories and all of this diversity, and also I only have this much data. And at the end of the day, really no solution is available to the data doesn't exist.
Mhm.
You have to have data in order to do something with it. This just does a little bit more with a little bit less than our
Mhm.
conventional approaches. But at the end of the day, we do still have that hard limit of, if you don't have data, you don't have data.
Yep.
So if you have an empty group, you have an empty group. Maybe they don't get to be included in that particular analysis because you don't have any information on them. If you have a few people, maybe depending on the situation, there's something that you could do to try and still be more inclusive and to keep them standing out and doing an analysis with that smaller sample size. I would say, yeah, sometimes you have to recombine things, different groups, and make compromises there because you still have some practical limitations. But my hope is this will encourage us to be even more diverse in how we collect our data. We're going to be a little bit less afraid to go out and try and actually recruit with greater attention to diversity intersectionally.
Yep. Great. Fantastic. We will leave it there. As you can see, we could spend the rest of the day and all through the weekend having this conversation. I put a link in the chat. And so anybody who didn't get their question answered or is going to try this and maybe have 4 or 5 more questions, keep asking your questions. That's what the Data Equity Forum is for. You can put it's not a membership site. You don't have to pay money to ask a question. Ask questions. We'll get you the best answers we can. So we're all in this together and we can work it out together. Claire, I cannot overstate how valuable this was. Great technique, fantastic presentation, and super, super fabulous kids.
Thanks.
All right. So thanks again, Claire.
Thank you all.
For everybody who attended, you all being part of the community that cares about these things is really, really important. So take really good care of yourselves and each other, and we'll see you next Friday.
Thanks, everyone.
Bye, everybody.